x squared. So remember, if you're not quite sure where does this graph come from, let's try a negative value and some positive values. So I'm just putting them into the function. So I'm going to do negative 2 squared. What's negative 2 squared? 4. What's negative 1 squared? Negative 1 squared should be 1. What's 0 squared? 0. And then we're at 1, 4. Okay? So we're going to graph these points. We did this earlier this school year. So right now, turn and talk with your team. What is this graph going to look like? Or what's the equation going to look like when we move it 2 units up? And then they want us to graph this in a different color. That's why I asked you to get pens today. So can you talk to your group? What does it look like when you move it 2 units up and then graph it on paper with a different color? The equation would be y equals x squared plus 2. Great, plus 2. And then I'm just going to shift all these points up 2. And then I can sketch that in my new color. Questions about an up or down shift? An up or down shift with our parent function. All right, number 2. We're going to graph the square root of x. We're going to graph the square root of x. And we're going to move it. Okay, so first, with your group, graph the original. If you're not sure, just select some points. I would look at the square root of 0. What's the square root of? Square root of 1, the square root of 4, and we're going to graph. Okay? I'm going to graph the major points. And then what happens when it moves right? What's the equation look like? What does it look like on the graph? So take a minute and work on 2 with your group. The square root of 0 is 0. The square root of 1 is 1. The square root of 4... Square root of 4. Should be 2. Graph these nice whole points. We're square rooting. That's our parent function. Yeah, good question. What's the equation going to look like when I move it to the right? Y equals... When I move it to the right. Negative x minus 3. Yeah, x minus 3. And it's under the root. It's under the parent function. And I can just shift these over. 1, 2, 3. 1, 2, 3. And that's that same parent graph, but now it shifts to the right. Number 3, an absolute value. Absolute value. What does that do? Can anyone describe what absolute value does to a number? A straight line? Part of it will be a straight line. What does the absolute value do to a number?
Makes it go like the graph or the number. The graph goes.
And a V?
Yeah.
The graph goes on a V. What does it do to a number? If I put in a number. Turns it positive. So let's graph some values. Let's start at negative 2, negative 1, 0, 1, and 2. So if I put in negative 2 into my absolute value, positive 2 should come out. Positive 1 should come out. What's the absolute value of 0? 0, 1, and 2. And we're graphing it. And you guys are right. It is going to have a V shape. It will be straight. There's no curves. A V shape. Okay, now they're doing a combination. We need to move it up 2 units and 3 units to the right. So what is this equation going to look like? Up 2. Does that go on the inside or the outside of the parent function? Outside, good. So plus 2. What should go on the inside to move it right 3? Minus 3. Okay, and then we're going to shift it. We're going to go up 2. All right, 1, 2, 3. Up 2. 1, 2, 3. Questions about parent graphs? Number 4, we're getting into our new parent graph. Okay, so all of that should have been reviewed from first semester. So number 4, we're getting into our parent graph. And we're going to do this one together. We're going to fill out this table. Okay? So first, we need to fill out our table. Our parent function is 1 over x. So in our calculator, will you do 1 divided by negative 5? Will you do 1 divided by negative 5? What's that going to be? Negative 0.2, so we can put negative 0.2. And then the next one's going to be 1 over negative 2. That's going to be negative 0.5. And now we're starting to get into the whole numbers. I've got 1 over negative 1. What would that simplify to be? Negative 1. And now let's check it on our calculators here. Now you're doing 1 divided by negative 0.5. Will you check that on your calculator? What happens when I divide by a decimal? What's happening here? 1 divided by negative 0.5. You get negative 2? What? No, you're correct. We get negative 2. We got a larger negative number by dividing by a decimal. When we divide by smaller numbers, we get larger ones. So I want you to type in 1 divided by negative 0.2 now. What happens? What's the next y value? What's the next y value? Negative 5. Okay, now everybody, take your calculator. What's 1 divided by 0? Everybody, take your calculator. What's 1 divided by 0? What's 1 divided by 0? Error. Are we getting an error on our calculator? It's undefined. Don't write error. Write undefined. Can I divide by 0? You cannot divide by 0. Right now, with your group, finish the rest of this table and then graph it. All right, we're going to graph this parent function. When you graph it, you have to be kind of careful with the decimals. I would try to graph those whole numbers first. So down at negative 5, we're at about negative 0.2. So we're really close to the x-axis. At negative 2, we're at negative half. At negative 1, we're at negative 1. At half, we're at negative 2. And then at negative 0.2, we're down here at negative 0.5. So this is what the negative side of the graph looks like. At 0, it's undefined, meaning we will not have a point. So let's go to the other side of this graph. At 0.2, our y value is 5. At half, our y value is 2. At 1, it's 1. At 2, it's half. At 5, it's at 0.2. So our other side of this graph looks like this. And this is our rational function. This is our rational function, the parent function. Okay, we talked about all the other parent functions, quadratics, square root, absolute. This is our new parent function. It says, are there any asymptotes? Where are they? This is where we're going to need some color. We do have an asymptote. We have a vertical asymptote. It's at x equals 0. I have a horizontal asymptote. Right here, it's at y equals 0. The vertical asymptote is at x equals 0. The horizontal asymptote is at y equals 0. Again, I'm trying to color code so we can differentiate and see the difference. So vertical ones go up and down, horizontal are the horizontal ones. I just abbreviated this. VA for vertical asymptote, HA for horizontal asymptote. Questions about our graph? Right now, I'd like you to turn and talk with your group. Can you discuss how are you going to move this 2 units up and 2 units to the right? Can you discuss with your group? Can you sketch it together? Here we go. We're going to move this 2 units up and 2 units to the right. So if we go 2 units up, that means my horizontal asymptote is shifted up too. So here's my new horizontal asymptote if I go 2 units up. If I go 2 units to the right, now my horizontal asymptote is at x equals 3. And then I'm going to sketch it from there. So I think it's most helpful when we sketch it around these asymptotes. That's why it's important to identify them. Can you tell me your equation? You had a great equation. Can you tell us the equation? What is it?
1 divided by x minus 3 plus 2.
Fantastic. Thank you. That would be the equation. Okay? 1 over x minus 3 plus 2. Okay, we do have a fraction, so we're dealing with a rational. Okay, what questions do we have about our new parent function? We're adding our quick notes to our notes. Here you go. Sorry. If you're going to cut and paste, there are 3 to a paper. Will you share it with someone? There are 3 to a paper. Will you share it? If you do decide to cut and paste, I would take your 2 different colors and color code your vertical asymptote, your horizontal asymptote, to show that clearly on the graph. So if you did decide to cut and paste, I would highlight those. Okay, so we're going to go to the check for understanding. And it says we need to transform this function 4 units to the left and 3 units down. So we need to write the equation first so we know what we're typing into Desmos. 4 units left. Where should that go? Left and right. Is that my H or my K? H. So it's going to be x plus or minus 4 then. Plus, remember it goes opposite. And then that shift down of 3. What's that going to look like? Minus 3. Okay, and so this is what we're going to type in Desmos right now. We'll make a sketch. We're going to look at our asymptotes. Okay. So now will you add this to your check for understanding? Again, I think it's easiest when you graph your asymptotes and sketch around it from there. So you're adding this to your check for understanding. And then we'll move on. Oh, we have to start domain and range. We'll do domain and range together. Okay, so we practice that. Okay. So you're sketching that on your paper. Okay, we'll do that right now. So if you make a quick sketch from what we did on Desmos, this is our graph. Let's describe the domain and range. Your domain is going to be all real numbers except So we're adding this in, except what can x not be equal to? Where am I getting my asymptote? The vertical one. Where's my red asymptote? Yeah, it's at -4. So I have all real numbers for x. Remember, this symbol means not or cannot be. So x cannot be at -4 because I've got my vertical asymptote there. So that's the only big difference when we're describing domain and range for these functions. The range is going to be all real numbers, except what can y not be? Where's the other asymptote? At -3. Good. Okay. Questions? All right.